Hi, myself ABHAY. Today's topic of my presentation is synthesis, characterization, and biological evaluation of some pyrimidine derivatives. So let's start with slide number 2. So as we know, bacterial diseases are one of the prominent causes of the death worldwide. During the 20th century, vaccines for the bacterial toxins and many other common acute viral infections were developed and made widely available. Despite of the advances in the antibacterial and antifungal therapies, many problems remains to be solved for most of the available antimicrobial drugs. So, to identify potent candidates in antibacterial and antifungal domain is urgent global need of mankind. Heterocyclic compounds containing two nitrogen atoms in the molecule exhibit significant biological activity, including antimicrobial and other pharmacological effects. Preclinical data from literature survey indicates that the heterocycles in association with the pyrimidine has shown good antimicrobial, antioxidant, anti-tumor, analgesic, and anti-inflammatory activities. Pyrimidine being an integral part of DNA and RNA, which imparts diverse pharmacological properties such as effective and bactericides and fungicides. So, considering above problem and taking consideration to importance of pyrimidine in medicinal chemistry, I aim to synthesis and characterization of pyrimidine derivatives and their antimicrobial activity. So let's move to slide number 3, which is more particular about the materials and methods which were used for synthesis of pyrimidine derivatives. All solvents and reagents which were used for synthesis of pyrimidine derivatives were purchased from sigma Aldrich chemicals and S-defined fine chemicals. Melting ranges of all synthesized compound was determined by GLNR select apparatus. The new compounds were analyzed with FTIR spectrophotometer. 1H NMR spectra were recorded on Bruker DRX 500 spectrophotometer at 400 MHz using DMS as a solvent and trimethylsilicon as the internal standard. The mass spectra of the sample were recorded using instrument LC MSD TRAP XCT. So we move to slide number 4. Here the slide is more about the chemistry and the synthesis of pyrimidine derivatives. The scheme 1 illustrates the way the target compounds were prepared. The general procedure for the synthesis of pyrimidine derivatives 4A to I is compound 2 reacted with different kinds of sulfonyl chloride in presence of triethylamine base in dichloromethane solvent. At room temperature, the reaction was completed in 7 to 8 hours, and the progress of the reaction was monitored on thin layer chromatography. Upon the completion of the reaction, the solvent was removed under the reduced pressure and the residue was taken in water and extracted with ethyl acetate. The organic layer was washed with 10% ammonium chloride solution and the final water wash was given to organic layer and dried the anhydrous sodium sulfate. The solvent was evaporated to get crude product which was purified using column chromatography. And the purified compounds was confirmed by characterization using spectral studies, and all the compounds were tested for antifungal and antibacterial uh, activity. So let's move to slide number 5. This is about the results and conclusions. So synthesis compounds were characterized by elemental analysis, FTIR, 1H NMR, and mass spectral studies. About the antibacterial activity, compound E exhibit an elevated antibacterial activity against gram-positive and gram-negative bacteria. Rest of the compounds are also show good and moderate activities. About the antifungal activity, compound E showed good antifungal activity with 96.96% inhibition when compared to other compounds in the series against F-oxysporum. Rest of the compounds also shows moderate antifungal activity. Again, F-oxysporol. The good inhibition by compound E could be attributed to the presence of electron withdrawing trifluoromethyl group. So, in conclusion, a series of new pyrimidine derivatives 4A to I were synthesized and their antimicrobial activity has been evaluated. Compound E produces significant changes in the activity against gram-positive, gram-negative, and fungal strains. Therefore, compound E can be considered as a good antimicrobial and it can be developed as a potent antimicrobial agent in near future. That's it from my side. Thank you all.